Okay, in this video we're going to analyze two more arguments and we're going to see some valid arguments this time. In the previous video I think we looked at 5 different examples, all of which were invalid arguments. And I sort of said at the end of the video that seems to be the case with most arguments that people make. Or at least in the examples that we're seeing. So let's see if we can make Euler diagrams for these. 2 premises in this one. No homeowner has a dog. So the quantifier here is the word no. That's a universal quantifier. The sets that we're looking at are homeowners and dog owners. That's the 2 things that are being described here. Now, let me make a circle for homeowner. I know that I'm going to need a circle or a set for dog owners, and how is that going to interact with the circle of homeowners? Should the circle for dog owners be inside the circle for homeowners? Well, if that were the case, then all dog owners would also be homeowners because they would also belong to this larger circle. That's not what this premise is saying, so I can't do that. Can the circles intersect? Should I draw a circle here, like a standard Venn diagram, for dog owners? That would imply that some dog owners are also homeowners. But this premise is saying that that's also not true. By saying no homeowner owns a dog, these 2 sets should be completely separated. Dog owner. Okay? So the first premise is giving us a diagram that looks like this. Second one, every car owner has a dog. So where should I put the set for car owners, because that's going to be the 3rd circle that I need? Well, if every car owner has a dog, I would need the set of car owners to be completely contained in the set of dog owners. If any part of the set of car owners is outside of this circle, then that would imply that there are some car owners that do not own dogs, which, according to this premise, is not going to be true. So I need a circle in here that says every car, or sorry, that's represents car owners. Okay. Now, let's think about the argument, or the conclusion. No car owner owns a home. If you think about how we did these premises, I had to draw this diagram this way. There was no other way to draw it, because this set of car owners has to be completely contained in the set of dog owners, according to my second premise, and this set of homeowners has to be completely separate from the set of dog owners, according to the first premise. By implication, then, we see that this set of homeowners cannot intersect this set of car owners, because in the process it would also be intersecting the set of dog owners, which can't happen. So that means none of the car owners, if you have a car owner, they live here inside this smaller circle. None of the car owners should be in the set of homeowners. That means that this conclusion is definitely true in light of the truth of those premises and making this a valid argument. And again, I need to emphasize, this conclusion in reality is definitely false. For example, I'm sure you know somebody, you may even be somebody who owns a car and a home. If that's the case, if you own both a car and a home, then this premise is not true. In fact, you go into any suburb and the homeowners there, almost all of them should have their own cars. You know, that's just observation. We see that that's true. But remember, judging the validity of an argument has nothing to do with whether the conclusion is true or false in reality. It's only, what we only care about for this is whether this conclusion is a direct consequence of these premises specifically. Now, these premises are not necessarily true in reality. For example, to say that no homeowner has a dog, that's pretty blatantly false in reality. But for analyzing an argument, it doesn't matter if the premises don't make any sense, because we're always assuming that they are true and trying to see whether or not the conclusion follows. I know I sound like a broken record with that, but this can be very difficult to wrap your mind around, how we're analyzing these arguments when we take something that looks like a true conclusion, or sorry, a false conclusion, and calling it valid. And remember, the conclusion is not what we're saying is valid. The argument is what we're saying is valid. Okay, this will be the last one that we look at. Some cows have a name. So some existential quantifier, I have two sets, a set of cows and a set of things with names. So let's say cows. Because it's an existential quantifier, these should intersect, but neither should be completely contained in the other. Things with a name. Okay? Now, all creatures with a name live on Earth. So a universal quantifier. And it's saying that all things with a name live on Earth. So I should have a bigger circle of things that live on Earth, and it should completely contain the set of things with a name. Now, should the larger circle contain both of these? It could, but we have nothing that would imply that that's the case, because nowhere does it say that all cows live on Earth. I think that's probably true, but that's not what the premises are implying. So I don't have enough information to say that the set of things that live on Earth should contain both of these circles. The premise only implies that this circle here should be contained in the set of things that live on Earth. Okay? What's the conclusion this time? Some cows live on Earth. Well, if something is a cow, then it has to belong to this circle, titled cows. It could be in three different parts of that circle. It could be here in that intersecting region. It could be here in that little region. It could also be here. Okay? Now, if the cow is here, then according to this Euler diagram, it does not live on Earth. It's an alien cow, I guess. But that alone would not prove this false, because this conclusion does not say that all cows live on Earth. That would be a false conclusion, because I can find one that doesn't out here. It only says some cows live on Earth. So if I'm able to find any X, any place that I can put an X that belongs to both the set of cows and the set of things that live on Earth, that's enough to say that this conclusion is true. And by the way that this diagram had to be drawn, that's of course going to be true. Even if I did the circle of things that live on Earth contain both of these circles, you should see that the conclusion is still true. So no matter how I draw this diagram, I have a true conclusion following from these two premises. Another valid argument. Okay, that's going to wrap up this section for us.